In the last video, we basically made it so when we run Sokoban, we can do this, and then we can do this, and the block will actually move. If we do like this, we do a bunch of stuff, and then I just press U a bunch, we will still have undo for the block at the right point. And we did that with a linked list. Now, somewhat mysteriously, or not really mysteriously at all, because I said why we were calling it a pooled linked list as opposed to just a linked list. And that's because we are going to implement an object pool, and the object pool is basically going to make it so we're not mallocating and reallocating a bunch of stuff. So what we're going to do is we're going to make our object pool. We're going to make it a header file, of course, right? Nothing crazy there. And yeah, we're just going to start implementing. So as per usual, pragma once so I don't forget. I'm going to be using a vector here. Down the line, we could get rid of it, frankly, but for right now, it's just a very convenient thing. And we're going to need a dynamic array anyway, so it's probably the right call, to be frank, just to use the STL version, unless we really start running into issues. So std : vector, right, and it's going to be of type t star, pointers to the type of t. Name it pool, why not? There's going to be no initializer because there's nothing to do, and we're just going to name it this. This is our deconstructor. This needs to be indented, and then we'll do for t star t in pool. So this is our deconstructor. Right now, there's no reason really to do this, right? Because there's no actual values in the pool, but we're about to fix that with two functions. So t star is going to be called getObject. T star is the type, getObject is the name. And getObject is not const. Yeah, it's not const. Just thinking out loud. So if there's basically two cases, right? In the first case, the pool is empty, so we need to actually make a new. Is there like an isEmpty thing? Empty? Yeah, that's better, right? So if it's empty, t star object is equal to pool.back. Then we do pool.popback. So this is where we're getting the element at the back of the list, or the vector. We're doing that because if, for example, like this is our vector, these are the elements in our vector. If we were doing like pulling from the front, you can't just delete the first, you have to shift everything over. So that's just a O of N operation. So it's just a little bit better. And then we're just going to return the object. So all of a sudden, when we have elements in the pool, we don't actually have to worry at all about mallocating anything, right? We can just completely ignore that operation and just keep going. But if getObject fails because the pool is not empty, then we have to return a new template like this. So it's not perfect. And you can also see we're relying on a default constructor. So right now, our implementation of this actually doesn't work. So let's fix that while I remember. T, nothing, null pointer, and next null pointer. So there's our default constructor for pool nodes. So now what we're going to do is in our other case, return object. We're going to take a t star object, and then we're going to do pool.pushback object, and that's it. Super simple, pretty clean. Okay, so now we go into our pooled linked list. We don't need IOStream, so we can just get rid of that. We fixed the pool node, but we're not actually using the pool. So let's do that. Pool of type, it's going to be of type pool node, type T, this pool. Pretty good. The default constructor is fine, so we're not going to give it any arguments. In terms of clear, right, this is our first case where instead of deleting, what we're going to do is pool.return object type temp. Right, so we're keeping the pool node, and we're going to use it for later if necessary. Next case, we're going to go into push front, nothing to be done here. Actually, no, that's a total lie. Well, instead of a new node like this, we're going to do two things. New node data is equal to data, and then we're going to get rid of this. We're going to do pool.get object. So what's going to happen, right, is if it's empty, we're going to make a new object. So that's exactly what we had before. Well, if it's not empty, oop, good thing I caught that. And since we're doing it like that, by the way, we can just drop the else, do this. What I did that, there we go. And that's a lot cleaner. So if it's empty, we're going to go through and actually allocate some memory. But if we don't have to, we're not going to. So there's that. And then we have to set the data rather than using like a default constructor. Okay, in this one, it's the exact same thing. New node, data equals data. Right, and then we do pool get object. Let's see where our next thing is here. So instead of deleting temp, we can do pool.return object temp. Pretty simple. This one, right, same idea. Pool.return object temp. I kind of don't like the temp object anymore, so I'm just going to make object. And then we'll do this one, object. We have a couple cases of deletes. So in this one, pool.return object front. I'm going to do a new line now because that's a little cleaner. I'm going to name this object, delete this, pool.return object, object. So that's fine. Let's go into this one. This is our last one. Pool.return object back. We do this. Return object, object, and boom. Let's see if we have any compilers. I don't think we do. Nice. Sokoban, let's run it. We're using our object pool. So we're just allocating a bunch right now, but then if I do this, all of a sudden we're not going to be allocating. So let's actually like log that real quick just so we can see it in action. So there's going to be log debug, alloc, and we're just going to call log debug. What do we want to name it? Get pool like this, right? So it's consistent. Pool this, this. Now we can make it. Now we'll do a quick little thing. So I'm here. So we're expecting 1 alloc, 2 allocs, 3 allocs, 4 allocs, right? But now I'm here. So we'll see how many allocs that is, but we're at least 4 allocs. But since there's 6 moves, I assume there's a little bit. I think we may just be at 4. Let's take a look. Doesn't show right there, so we have to do this. So we had 6 allocs total, which makes total sense. But you can see here, yeah, that makes total sense. So right here, you can see rather than actually reallocating memory for these moves that we were undoing, we could get them instead. Now, if we wanted to take it a little bit further, right, where we really are concerned about when we want to allocate memory, so like if, for example, per frame, there were some frames where we knew we just wouldn't be able to allocate more memory just because of time constraints. What we could do in our object pool, we could add something like avoid alloc more, right? And it could take like an std size t, size, and then I think I'm actually going to implement this. So I is equal to 0, I less than size, plus plus I, right? And then what we do is pool.pushback new t, right? And all of a sudden, if we really wanted to do it like this, right, we could go into our pooled linked list. Well, I'm not actually going to keep this, but just for funsies, if you will, if we take this and we do like pool.alloc more, right, And I actually need to fix, oh no, we did this, cool. So we can actually show that too. If I just alloc like 20 at the start, so we do this, Sokoban, play, let's do this one, right? I'm doing this, I'm gonna undo some moves, now I'm gonna do this, now I'm gonna do this. If I check the log.txt, actually we'll do another level just to kind of show this. And we'll do this again. Undo sometimes, undo that. Oops. Now we're gonna beat it, close the logs. And you can see at no point, ooh. So you can see when we started loading a level, we started allocating memory, which is interesting, right? Because we didn't really want to be allocating memory after this point. So that to me signifies that we have some kind of leak going on here. Pool temp front. Let's name this object real quick just for me. Alloc more. So that to me signifies basically that we have some kind of problem right here. So this is actually kind of good because what I was planning to do was for the next video was to use something called, because like what I really want to use is I want to use something called Valgrind. But if I try to use Valgrind on my Mac, oops, I can't type sometimes. What's going to happen is, I guess it's going to say this, where Valgrind has an unsatisfied requirement for this build, which is that you need Linux. Basically meaning I can't run Valgrind on my Mac. So what I was planning to do for the next video anyways was to use this thing called Leaks, which is a tool apparently made by Mac OS, which will look for leaked memory. So I have a feeling that even though we could just debug it now with our log file, because I'm pretty sure I know what the problem is at this point actually, we're going to use Leaks to actually figure out if we, one, have a leak. So if we do have a leak, then I'm right with the problem. But if we don't have a leak, then we're going to just figure out how to use leaks in the first place. And so that's going to be in the next video. In this first one, we made an object pool where there's unfortunately a bug, but that's totally fine. That's just part of development. But in the next one, we're going to use leaks and we're going to actually figure out where the problem is. So yeah, I'll see you in the next one. Bye.